Alright, this is my video on critical thinking in a chemistry course. So what is critical thinking? And I looked it up a little bit, and what I found was critical thinking is the ability to think clearly and rationally, the ability to engage in reflective and independent thinking, which many students struggle with. And I really liked what this had to say. It says critical thinking can be thought of as evaluation thinking, in which students or people need to evaluate actually what they're looking at and what they're reading. Um, Critical, often people think critical, they think, um, being critiqued, whereas evaluation thinking, I think, fits it better, where students and different people are having to think about what they're looking at and what they're working with. Students who are critical thinkers are able to, first of all, understand logical connections between ideas. In my classroom, that's very important, since in chemistry so many things build upon each other that it's important to understand the connections between them. Identify, construct, and evaluate arguments. Um, we don't argue a lot in there, but in different things we do, they do support or try and defend or explain at least what findings they had and why. Detect inconsistencies, common mistakes in reasoning. Again, you're looking for patterns, you're looking for things that make sense. And then solve problems systematically, and this is probably the most used in a chemistry classroom, since many of the calculations we do, many of the things we do have certain steps, and students need to look at step 1 to step 10 and how to go about doing that, and as they go along, where errors might happen or what's going on there. And then identify the relevance and importance of ideas. And I think that's just kind of important for any learning. You need to help students understand, and students themselves need to understand why is this learning relevant to them. And once they're able to do that, once they're able to understand that this point is important and has relevance to either the class or their lives, I think they're more willing to think about that. Critical thinking and rigor. In our school, we are really big on rigor and relevance. We're part of a group of high schools that promotes that more and more. And so we have a lot of the time when we discuss critical thinking, we discuss lesson planning, we have these 4 blocks, and basically all of our lessons we try to get up into the C and D range eventually, which both of those, in particular D, would be more of the critical thinking part, where you're getting students to think on their own and think in complex ways. And basically we try and do that. The A and the B area is basically your basic, vocabulary notes, that kind of thing. But in chemistry in particular, especially when we're doing laboratories and things like that, we're trying to get those students up towards the upper, higher level thinking, and trying to evaluate what they have seen and how they can use that. So many of my students in the beginning in particular, but even as the year goes on, when they're asked to think critically, this is basically what they expect. They basically expect for me to tell them the answers. Often, when we're doing a lab, for example, what do I do now? What do I do next? And, we refer them back to their procedure, read the procedure, and think about it. So a lot of kids really just kind of want the answers until they learn how to think and understand that it's okay that they think on their own. So in my classroom, basically, how do we promote critical thinking? And we do this in a lot of ways, and a lot of times we don't really think about it. But first of all, like I said earlier, we try to make connections or bridges between subject matter, so all the pieces come together. Often we're referring back to something we've already learned that then fits into what we're currently working on. For example, then, valence electrons, we talk about those first. Those are the electrons in the outer shell. Then we talk about electron negativity trends, how those electrons are going one way or the other, which then leads us into bonding. And as we go through steps, kids kind of make those connections. Another one is molar conversions, which then leads us into stoichiometry, which then we can turn around and use that idea into ideal gas laws. And so if we make connections, I think the kids understand and can think on their own. You know, if I know this and I know this, I can figure out a way to do something about it. Another thing we do is we try to do a little bit of open-ended experiments where they have to interpret the data in the graphs when they're using computer probes um, or traditional instruments as well. So if we have these different probes that take readings and graph, then they need to interpret what that is meaning. Um, Often we try to ask the students then to use this information to identify an unknown substance. It's usually, you know, it's obviously a substance that they've already tested, but based on their data, they've got to make a judgment on what they've been given when they test it and looking back at their things. This requires them to think a little bit about how they go about conducting the experiment and how they read the data that they take. In the end, then, students evaluate results and explain errors that occur in their labs and their conclusions. So they have to sit down and have to think back in their minds, and they have to self-evaluate what they did and what they saw and why maybe it didn't work out as well as it should have. And they explain that, they verbalize that in their writing, and that's part of every lab we do. And then finally, we try and come up with transference to many of the topics we're discussing. Because if we can create a transference between what they're doing in the classroom and what they see around them, they're more willing to think about things and make those connections. So for example, a soda can exploding in the back of a car window in July, okay, we discussed that. We can explain this by many different subjects we're talking about. The kinetic molecular theory of gases, how gases move consistently. Gay-Lussac's law, which is pressure and temperature being directly related, in which as temperature goes up in the back of that window, the pressure of the gas is going to go up, and that's going to cause problems. Eventually the can just can't take it anymore. And also solubility rules. We talk about how gases are less soluble the hotter they get, the hotter the liquid gets, and thus again they want to escape. So all these different things we can refer back to something that they see in everyday life. And so these are just a few ways that we try and promote higher level thinking and try and get the kids to do these type of thinking and critical thinking. So in the end, basically, as this picture kind of shows, I try and get my kids to realize everything's a puzzle. And if you know one piece of the puzzle, you can put it with another and another and another. And eventually, on your own, hopefully, you will be able to put the pieces together and find an answer to whatever problem is posed to you.